Hi, my name is Joyce Simbala and you are on I Am Joyce. This is the place where we talk about business, real estate, manufacturing, travels and lifestyle. And you know we cannot put all that together if we don't talk about technology, because it is the driving force that has crept right into our society and it's helping us to make things work and for things to work better. And why am I sitting with all this beautiful stuff in front of me? I'm not going to mention it because I'm going to tell you about the man that made all of this. So today I'll be introducing to you Mr. Ayodele Tayo.
Thank you very much.
Okay, you're welcome. So Mr. Ayodele Tayo is an architect by discipline, right? By profession. He's an architect, but he's gone beyond architecture to building, making, innovating, whatever you can call it. You can see all of this in front of me. So he's going to tell us product architecture and so many other things. So I will allow him, because I don't understand these jargons, I will allow him to explain what he does. So you're welcome.
Thank you very much. So basically, what this is about, it's product architecture.
Okay.
And architecture, as we know, is what people actually take architecture to be is just designing of buildings.
Yeah.
But architecture does not really stop there. You know, there's an aspect which is product architecture, which is it's similar to the regular building designs, but in this aspect, it's products.
Okay.
And when we're talking about products, it goes a long way from manufacturing of cars to your tablespoon. I mean, it cuts across all fields. And it's quite important because people usually make a mistake of combining product designers with product architectures.
Okay, I thought it's product design because I wanted to say product design.
No, product designers are actually different. Well, the basic difference between them is someone designs a product just for aesthetics, okay? Seeing the product, how it will look, the appearance, basically. However, product architecture deals with the internal arrangement, including the look, including zoning of either the temperature region or possible, and most importantly, with experience or maybe users' experience or user interaction with your product. That's what product architecture is all about.
So I used to hear this word, design ergonomics. So when you talk about user, the person using it, experience, so you know, maybe somebody using a wheelchair, for example, and you know, wheelchairs improved over the years. When you design something, you want, now they have brakes. I noticed wheelchairs have brakes. Then depending on where you are pushing the person, you know, whether it's a slopey environment or the comfortability, depending on what the injury is. Okay, so that's what
the user experience is all about. How the person interacts with that product. If it's comfortable, if it's easy to use, and also there is also easy to produce. Because product architecture does not only deals with the user experience only. There is also consideration for how it has been made. Yes.
That's interesting.
So a product architect usually goes through all the phases while doing its design. You're supposed to know the end, meaning how it will be produced. Is it going to be a blow system production, or is it going to be a 3D printed item, or is it going to be an injected? So knowing that with shipping, how you would design your product.
Okay,
so that's
interesting.
That's why product architecture is quite important.
Now, did you learn this in school, in some Nigerian school? Did they teach you product architecture in school? And if you did, are there laboratories where you learned or workshops where you learned some of these things?
Well, no.
Okay.
However, because I've always been fascinated with how products are made, so I took quite some time to do both research, learn online, and also had interactions with company owners and, you know, their manufacturing system. So that actually shaped over the course of about 8 to 10 years. Right, that shaping that made me gather a whole lot of knowledge on how to make different products.
Wow. So these products in front of me are some of the products that I see in supermarkets. Some in supermarkets, some like toys. Yes. You know, some of these figurines that you use for decorations. You see them in people's offices. You see them as backdrops on shelves in people's houses and all of that. But most of these things are imported. So, but you said you made this right here in Nigeria, in the city of Abuja. Yes. So, how did you come about this?
Well, some of it, were just to try the limits of the machine, 3D printers. And in the process, we decided to start making things that are missing in the society. For instance, what would make education easier, right? If you go under chemistry, one will realize that chemistry is quite a difficult course because most of the time they are imaginary. Speaking of what is the boiling point of maybe carbon or maybe or boron, something like that. It's quite difficult, and yet we'll be asking kids to memorize all of that and to put them in exam. That's the reason why a majority of people are not going into...
What do you call it? Okay, I remember this is, what do you call this thing?
A periodic
table. I remember we used this. Point. So, and this can be a learning tool.
Yes.
And this is all we know, whether in our books and all of that. Exactly. But we are not taught how to transfer this knowledge into making something that is physical. For
instance, right? This is carbon over here, right? The highest element. Just looking at this, and because I've told you this is carbon, which is the highest, if you can see it, right? If I should take this away and ask you in an exam that which element has the highest boiling point,
I'll say carbon easily.
It's just so easy for you to remember because you interacted with it, you saw it, you can visually remember it. Now that is what makes majority of this product important in schools. So we started making them using 3D printer, of course, which is a lot easier than making a mold for it and then injecting it, which that's for mass production. However, 3D printing solves a lot of these issues.
Okay, right? Before you talk about 3D printing, you know, this is very important because I didn't even see it from that angle. I remember seeing babies of 9 months already calling out numbers and can actually say something like state and capital, because I noticed in the Western world, they use a lot of toys and they use cards to teach children in school, something they can interact with. They've moved from just having a book. You know, here they teach us tracing, then you draw, then coloring, but you hardly see something physical that the kids can have in school and even take back home. When you see anything that is a toy, it's a teddy bear or a ball, something that does not really make sense to me. I think a lot of schools should adopt the use of some of these things, and they can be produced right here in Nigeria. Now, and most of these things that are sitting right here on this table were made with 3D printers. So let me just show a few of them. This, sorry, we came here and we kind of broke this. So if you're seeing this, this is, I think it's something like this, right?
Yes.
Yeah, it's something like this. So, and this is something, it's something like this. I know it's something like this anyway. So, if you're living in the city of Abuja, for example, you may have seen this image. And let me just give you an expo. This is, you know, Papal's ground. This is, they have a new building there and they have like a dome-like cover. It's not finished. It's like this. It's half its structure. And this is what they just copied from there and just made a replica of the dome. So it means that a lot of architects can come here and make their models, because this is a model, and this is the picture of city gates. You know, the structure, the model of city gates, and this is the femur. This is a bone, and you can use this as a teaching tool. This is another bone. This is another one. This is the image of the Virgin Mary, and a lot of people have this in their homes. They use it, and a whole lot of other things. So this is metal, but this is a replica of it in plastic. And you'll be wondering if you just went somewhere to buy it, but they made it right here with the help of a 3D printing machine. Now, one of the things I've come to learn is that 3D printing machines now build houses. Yes. But a lot of people don't know anything about 3D printing machines. What's the technology and how does it come about this?
Well, 3D printing is quite easy compared to how people visualize 3D printing. They take it to be this extreme technology, but it's quite very simple. It's similar to your regular day-to-day paper printing machine. However, it is not
paper printing. No, I've asked a couple of persons, do you know the 3D printing machine? They said, yes, now 3D. It's just print paper or flex or something like that. This is not paper. This is actually a machine printing something solid, like this, physical, something solid that you can carry.
Yes.
Okay.
Because the machine actually had something called the Z-axis.
Okay.
Right? Yeah, it goes forward, it goes left and right, and it equally goes up. So, which is done layer by layer, right? Meaning it melts plastic little according to your design, right? Which is quite simple to learn. In fact, it's something under a week one can be through with the learning, and you'll be good enough to operate or build.
That fast?
Yes, that fast. As far as the machine is concerned, right? Then the other aspect, which is people learning how to design. What is really missing in the society currently is people learning that it's important to design first. Like you see a lot of furniture makers, a lot of cabinet makers, what they just do is just take the dimension, do you want this and so on. That is actually the difference between a professionally made item or object and a local craftsman. So and the difference is just designing. You just need to design, right? Get all your parts proportional or accurate, and then you produce them out. And with 3D printing, it makes it so easy, right? You can decide to just produce one, see if it works. That's prototyping, or you can decide to just mass produce.
Wow.
Yes, yes, it takes more time compared to injection machine. However, if you need just 20, why go to injection machine when you can actually make this?
Wow, that's really interesting.
It's solid and
so I'm going to say this, what if you can actually make anything? If you can think it, imagine it, and you can put it on paper, design it, what if you can make something? What if all you've been dreaming about is making this type of lights, what do you call this? Lamp. This is a lamp. And we see a lot of this in big shops here in Nigeria. You buy this thing for 50,000, 70,000, 100,000 and more. But it's made right here. What if this was all you were imagining and you want to make this in bulk and sell? So you want to tell me that with 3D printing machine, people can have jobs. People can actually sit down and mass produce something and put it out in the supermarket or in the market for people to purchase.
Yes, actually. And it doesn't stop there because creativity is quite vast. That's manufacturing, basically. It's quite vast, and it depends on what you want to do. Like the lamp over there is made using strictly a laser machine, right? Cutting the parts and then putting them together. So there are different aspects if you want to create anything. Some might be metal, which you have to either use a high watt laser machine or a plasma machine for accuracy. And then but when it comes to certain intricate parts, even injection machine will not be able to do that for you. For instance, if you have to make something like this,
wow,
right, these are quite very, very detailed item,
even though it's very
so
tiny.
Definitely injection machine will not give you this, blow method will not give you this, thermoforming will not give you this, laser will not equally give you this. In fact, CNC, which is another good machine, will equally not get you this. So, but then that is the part where 3D printing comes into play.
Wow.
Right? It can get you to any level, right? Either small or either complex or non-complex.
And this can be something you used to play a game with, maybe chess.
Yes, that's actually a chess
So
part.
it's a chess part. You can have something like this. You can make something like this. All of these things can be chess parts. Wow. So that's a lot. So so Mr. Ayodele Tayo is the CEO of SATFORMS Limited. So SATFORMS Limited goes beyond what we have on the table. So you don't think it's one small company that is making miniature products. So this company has gone beyond all of that. All the innovations that you have made and all the technology involved is not just the use of plastic, right? Because most of these are plastic. We've also seen SATFORM produce metal. So maybe you just aluminium, metal. We've seen what do you call it? You have something like this, which is a mold. This is a mold for something, and you have all the machines that make this thing. Now, what makes SATFORM stand out to me is the fact that you guys are not just buying machines importing machines from outside the country to make this. You actually invent. You build the machines that make some of these things. How do you start becoming an inventor?
That's quite a long story, and it all started actually with 3D printing, right? 2013, okay? That was 2013. And well, I was still practicing architecture then fully. However, I had this interest. I've always been fascinated with how things have been made. So I got in touch with a friend who was able to link me up with a company which is RepRap, and they were able to send me a board, right, for me to try out, and then they kind of send me some few parts which I will need. However, it is left for me to do my own design. So 2013, I made the first 3D printer in Nigeria. Wow. Yes.
Made by yourself right here in Nigeria. Made by SATFORMS. Yes. Okay, let me just, because I'm asking this question is because I've seen the first 3D printer they made, and I've seen the advanced. You see it, you see it on your screen. We're going to show you what they're building, what is out there in the market, and what they're building presently. So you can go on.
Okay. So we made that first 3D printer, and then that really ushered in the knowledge, right, to understand 3D printing. And with that knowledge, I was able to understand making other parts, right? Because 3D printing is so fantastic that it can equally build its own self. Wow. Yes. So then we built another 3D printer, and then from there, we're able to make our own laser machine. We're able to make a plasma cutter machine. We're able to make an injection machine, but manual and semi-automated injection machine. And why we're doing that is because after you make a product, right, usually you want to mass produce for the market. Yeah. And the limitation with a lot of companies is that they are stuck with how would they make a mold, right? How would they make a mold? Because mold is quite expensive, you know, from China or Germany, or depending, it's quite expensive. So we got this idea where we're thinking, how about we use recycled aluminium, like your can, your roofing sheets, you know, just some aluminium part. How about we get it recycled, and then we try it on the machine and see what comes out. Right? Wow. Which we did, and it works out fine. That is what you're seeing. And we understand that a lot of people in Nigeria are not willing to spend hundreds of millions just to make mold outside you're just starting a business. Yeah. So that is one of the reasons why we went that route. However, yes, one can still get very good at recycling aluminium to, you know, to a perfect stage. And with that, one can make virtually any shape. Any shape. Of course, right now we're still limited to maybe the size of the mold. The mold. Right. However, we can still do quite reasonable parts. So
what's this right here?
Okay, this is we just tested this when we made one of our injection machine, which is the manual type, not even the semi-automated, right? And then this we just tried the star shape. Like let's see. So let's see
this like complex. This, something like this, so, and you want to close it up.
Yes. So all you just what it is that you have this will be, you know, carved out by your CNC machine, right? That's your computer numeric control machine, right? After that, you put them together, which of course will be tightened together, and then you put this is the channel, and then you put this right under your injection machine, and it liquefies the plastic, right? Semi-molten plastic, and inject it right into here, and then you have your part, which will be done maybe in less than a minute or 2 minutes. Unlike if this is to be 3D printed, this can take you roughly maybe about 30 minutes.
Okay.
So this, using the injection machine, cuts down time for you as a business person.
Yeah.
And
but if you're making few, it's okay to use the 3D.
To do 3D print.
So what's this mold for?
This is for a blow machine where they use bubble wrap. Bubble wrap,
okay. Yes. What they use to package?
Yes, what they use in
packaging products.
The bubble wrap, the cylindrical type of bubble wrap. Yeah, that's what this mold is for. It's for a client.
Wow, that's serious. Now, you don't just work with plastic, metal, you also work with wood, because I can see that the straws, this straw-like looking stuff on this, what do you call it?
Lamp.
This lamp is wood.
Yes.
And you also have this wood stand, you know, it could be made of, it could be any shape, and you also printed a name on it. So a name can be printed just like you have this plastic. I think this one is Alibat, the Alibat company, and their logo, that is what is on this very plastic. But you can also have them in wood. This is for like a hotel or a restaurant. You have their, what do you call it?
Okay, the barcode.
The barcode and all of that, so people can scan to pay for services or use as an entrance, a passage into a building. So if you can produce this, mass produce something like this, you are in money, because imagine all the people you can sell this to. So tell us more about using the machine and using what do you call it?
This is
wood.
Done by a laser machine.
Okay.
Right? And the advantage of using a laser machine is, with a laser machine you can either produce one or you can produce in thousands.
Okay.
Because it cuts pretty fast. We equally build our own laser machine over here. And not CO2 lasers, because there are two different types of laser machines. There's the diode and the CO2 laser machines. We make the diode laser machines over here. And but for the CO2, not yet. Yeah, later we'll get to that stage. So that does that, and that's an engraving, not actually printing. It's actually an engraving. It engraves on wood, and it actually cuts wood also. Wow. So,
and it cuts it so beautifully, like accurate.
Yes.
It's clean, it's neat.
Yes, with a lot of precision. I think about 0.02 accuracy.
Wow.
But it's thinner than your hair. That's how much, the little error.
That's a shade. But you know, so how can we translate this to money? Why are these important?
Okay, part of the challenge Nigeria has is true knowledge.
Okay.
A lot of people understand that, oh, this is being made abroad, and it takes a whole lot to do all of this. The true factor, right, like what people will say is enabling environment. But then I always keep asking myself, what is really enabling environment? Because enabling environment for a doctor is absolutely different for an architect, and it's also different for a technologist. It's different for also a manufacturer, right? Some, the enabling environment, well, generally I think we all need power, yes. However, for an innovator, it's more of space and also team members.
Yep.
Knowledge, yes, they will have to acquire as an innovator, right? For other aspects, you know, their own enabling environment is different. But for an innovator, it's simple, but it looks complex, and anybody can become an innovator, really. Right? It just depends on either your will, not really what you study. You can be an accountant. I mean, we've seen a lot of accountants become fashion designers and you know, all of that. Right? It's a function of your will. What is your interest? And you can be an innovator at any age.